my soul. Brand new dance, it's kind of Cupid shuffle. It don't matter if you're young or you're old. Here we go. We gon' show you how it goes. To the right, to the right, to the right, to the right, to the left, to the left, to the left, to the left. Now kick, now kick, now kick, now kick. Now walk it by yourself. Now walk it by yourself.
All right. Happy Friday, or whatever day you're watching this. Happy Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. All right. So this is 5.10, homework help. Oh, you're really far away. Here. That should be fine. Okay. This is a really good homework because it'll get you mostly prepared for the test. So I like this homework. I highly recommend doing this homework. Oh, 1 second. Okay, sorry. So the first three, you're given a system of inequalities, and you're given 3 points. And you have to determine which works. It says, determine if the given coordinates are solutions to the system. Show your work. All right? Give me a second. This is what you're given. I'm going to color code everything. I'm going to make all my X's probably purple, and all my Y's I'll make red. There we go. Okay. So what we're going to do is just one by one, we're going to substitute these points into the inequalities. So in order to be a solution, it must work in both. So we're going to start with 6, 10. And I need my black. There it is. So I'm going to substitute 6 in for X and 10 in for Y. All right? So we're starting out with the top equation here. So Y is 10. So you have 10 is less than or equal to 3. Substituting your X, which is 6. And then you have minus 5. Minus 5. Okay. So I substituted 6 in for X, 10 in for Y. That's all I did. I just rewrote everything else. Got it? Good. Moving on. So now we have 10. Okay. 3 times 6. 18 minus 5. Don't need that anymore. Okay, 10 is less than or equal to, see how I'm just rewriting? So I'm doing one step at a time, and I'm just rewriting everything else. 18 minus 5, 13. Okay, so you have 10 is less than or equal to 13. Is that true? Is that a true statement? You're still a little bit far away. Come a little closer. Okay, all right. Yes, that is true. So I'm going to put 1 check mark next to this guy. It works in the first equation, but it needs to work in both. So now we're going to do the same thing, except we're using this equation. Okay. So I'm going to, I need to eat lunch. I need to substitute 4 in for Y. Y is 4. I don't know why I have orange out. So we're doing this equation now. Okay, that's a terrible star. Is greater than or equal to X. X is 6. Oh, my bad, sorry. This is 10. I lost track of what I was doing. Sorry, we're using this point still. So Y is 10, X is 6. That's 6 plus 2. 10 is greater than or equal to 6 plus 2 is 8. All right, we're done. So is this a true statement? Is 10 greater than or equal to 8? Yes, 10 is greater than 8. I'd rather have 10 pieces of pie than 8. Maybe not, that's a lot of pie. Anyways, so this point is a solution. It works in both equations, so this is one answer. Okay, if you got it, go up. go on without me, but you have to try the other 2 points because you're going to have more than one answer here. So our next point, x is 1, y is 4. So we're going to go back up to the top equation. We're going to substitute into this equation. So y is 4, less than or equal to 3. Times x we're putting in 1, boop, 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 okay? Minus 5. All right, here we go. 4 is less than or equal to 3 times 1 is 3, minus 5. 4 is less than or equal to 3 minus 5. -2. And stop. Is 4 less than or equal to -2? No. 4 is greater than -2. So we already know this point does not work. It does not work in this first equation. Therefore, it is not a solution to this system of inequalities. It does not work. So B is not an answer. No. Let's try point C. All right, we'll start with the top equation again. This time, y is 15, x is 8. So I have y is 15, so 15 is less than or equal to 3 times x is 8, and minus 5. Okay. So all I did was substitute in for x and y. Keep going. 15 is less than or equal to 3 times 8. Oh, sorry, I got to pop up. We're good. 3 times 8 is 24, minus 5. So 15 is less than or equal to 24 minus 5. 24 minus 5 is 19. Okay. So there we go. Is this a true statement? Is 15 less than or equal to 19? Yes, 15 is less than 19. So this works. Remember. So we put one check mark here. Boom. But does it work in the bottom equation? It must work in both to be a solution. Right. So y, now we're on to this equation. Y is 15. Greater than or equal to x is 8. Plus 2. Right, so substitute in for x and y, and then 15 is greater than or equal to 8 plus 2, 10. Right, and you're done. Is this true? Is 15 greater than or equal to 10? It is true. So you put another check mark. So this point works in both equations, therefore it is a solution. So your answers are A and B. All right, so that's what you're doing for number 2 and number 3. All right, 4 through 6, you have to write every equation, write each equation in slope-intercept form. That's y equals mx plus b. All right, you want that form. So I will go ahead, oh wait. And then based on the slope-intercept form, determine whether the system has 0, 1, or infinitely many solutions. How do you know? I'll start with number 4. Okay, so here's number 4. I just color-coded it a little bit. Can you tell? Kind of. I made my x's purple and my y's are red. So our first step, following the directions, is get them in slope-intercept form. Okay, y equals mx plus b. Y equals M, this is your slope, X, B. All right, so this one's already there. Your slope would be -3. Your y-intercept, which is B, would be -7. So this one's already there. We don't have to do anything with this guy. All right, so we just have to get our top one in slope-intercept form. This one's good to go. He is Gucci Tucci. We're all good. We don't have to do anything there. So, I'll just rewrite this one below it since that's the one we're going to be working with. And wow. Okay. So we are transforming this equation into slope-intercept form. So I need to make it y equals. So basically you're solving for y, right? You want y to be all alone on one side of the equation. All alone. So you do PEMDAS backwards, pretty much. So what you're going to do is we're going to subtract 3x from both sides, not in red, because it's dying on me in blue. We're going to subtract 3x from both sides. Okay, so that will give you, this goes away, 3x minus 3x is 0. So you're left with -4, I'll add in my y, 13 minus 3. Let me switch markers, 1 second. You need time to recuperate. Okay. So, okay, -4y equals 13 minus 3x. We still don't have y by itself, but we're close. So you have -4 multiplied by y. -4 times y. So do the opposite. You're going to divide by -4. That means you have to divide everything by -4. Some of you like to just divide one of these. You have to divide everything by -4. Okay? Let me come over here. So you are left with, this is just -4 divided by -4 is 1. So you're left with 1y, which is just y. Y equals, and then on the other side, you have -3x divided by -4. -3x divided by -4 is, your negatives will go away, so that's 3/4 x, and then plus 13. Oh no, sorry, we have to divide. 13 divided by -4, which is, you can just leave it as -13 over 4. Positive 13 divided by -4 will give you a negative answer. Ooh, my shadow's like right there. Okay. So we changed it into slope-intercept form. Okay. Your next thing is, how many solutions will this have? So let me erase, so we're just back to our original two equations. Hold on. Okay. So now we have this equation and this equation. How many solutions will these have? That means if I were to graph these guys, you don't actually have to graph them. But if I were, how many times would they intersect with each other? Or would they never? They would intersect once. They have different slopes. This slope is -3. This slope is 3/4. So their slopes are different. That means at some point they are going to intersect with each other. Just once. They will intersect just once. Their slopes, they are linear. This is a line. This is a line. Okay, at some point they're going to cross. Just one time. So there's one solution. And it's because they have different slopes. All right. I'll get you started on another one of these. Okay, I'll get you, well, maybe we'll do the whole thing, I don't know. Here's number 5. Here's the first equation of number 5. You're given 2 equations. You're given 2 equations. This is just the first one. We're going to switch this into slope-intercept form. I'm going to make y be orange. And x doesn't really matter. Okay. We're solving for y. We want to get y all by itself. So similar to last time, we're going to subtract 3x. Oh, not in orange. We'll do it in blue. Sorry. Okay, 3x minus 3x is 0. So on this side, you are left with, don't forget about your negative, negative 3 y equals 3 minus 3x. Okay? You're not done. You need to divide by this negative 3. So divide everything by negative 3. So on this side, you're just left with y. Okay. Over here, we have 3 divided by negative 3, which is negative 1. And negative 3x divided by negative 3 is going to give you a positive x. Okay, your negatives are going to cancel out. And then let's rewrite this so it's in y equals mx plus b, so we just have to switch these. So y equals x minus 1. Okay. So that's the first equation. I'll leave that up there. The second equation they give you is x minus y equals 1. This is given to you, x minus y equals 1. Possibly? X minus y equals 1. Okay. Let me make y orange again. There. All right. So we want this in slope-intercept form. So you're solving for y. So my first step is I'm going to subtract x from both sides. X minus x is 0. So on this side, you're left with negative y, negative, equals 1 minus x. You're not done. You have to get rid of the negative. So divide by negative 1. Divide everything by negative 1. That'll give you y. These cancel out. So you're just left with y equals 1 divided by negative 1 is negative 1. And negative x divided by negative 1 is positive x. Okay. Then once again, just rewrite it. Y equals x minus 1. So those are the two equations you have in slope-intercept form. They are the same. They are exactly the same. That means if I were to graph these, they're exactly the same. They're going to be on the same line. So they have infinitely many solutions. Okay, so for number 5, it's infinitely many solutions because they're the exact same line. Your other option that you're going to run into is if they have the same slope, but different y-intercepts. So they have, like if this was, okay, now they have the same slope. They both have a slope of 1, but they have different y-intercepts. That means these lines are parallel. They are parallel and they will never intersect. Same slope, different y-intercept. We're parallel. We're never going to intersect. We have no solution. No solution. Okay. Okay. I have to do something else that involves my camera. So this will be part 1. Sorry I keep doing that to you. I'll post part 2 a little bit later, where I'll do some of the elimination ones and some of the graphing from the homework. All right. Hi.